Hello, we're looking at problem 1 from lesson 5-7. It says, making a scatter plot and describing its correlation. So we're looking at temperature. The table shows the altitude of an airplane and the temperature outside the plane. And so if altitude 0, the temperature is 59 degrees Fahrenheit. An altitude of 500 meters, my temperature in Fahrenheit is 59.2, and so on and so forth. So step A says to make a scatter plot. So they made a scatter plot. The temperature here was on my y-axis, and the altitude is on my x-axis. It says to treat the data as ordered pairs. For the altitude of 1500 meters here, the temperature is 55.5 degrees Fahrenheit. So 1500 meters would be about right here, and 55.5 will be right there. It says, what type of relationship does the scatter plot show? The temperature outside the plane tends to decrease. As you can see, I have like a negative correlation here. It's going down the hill like I'm reading it, like I'm looking at a book from left to right. It's going down the hill. So there's a negative correlation. All right, so let's do one on our own. It says, make a scatter plot of the data in the table below. What type of relationship does the scatter plot show? So I'm going to use a free graphing tool. It's called Desmos.com, and it's a free graphing calculator. And I'm going to do that because I think it'll be a little bit easier for me to graph it here than trying to use my whiteboard. So I'm going to put my dollars spent, gasoline. So I'm going to say my rationale will be my dollars spent will be my y-axis, because I'm going to spend the amount of money depends on how much gas that I bought. So back to my graphing calculator. So my x is 2.5, my y is 10. So I'm going to put that in. So 2.5, comma 10. That's my first point. Can't see it, so I'm going to zoom out. There it is. All right. The next one is 11 and 2.8. Set that backwards. Excuse me. 2.3 and 9. 2.6 and 10. 3.3 and 13. 1.3 and 5. 2.2 and 8. And 1.1 and 4. Okay, there are all my points right there. Okay, and we could just look at this and already and see. If I look at it like I'm reading a book, I'm gonna zoom in a little bit because I'm gonna need the positive. If I look at it like I'm reading a book, it's going up the hill, so it's a positive correlation. So the more gas that I buy, the more I'm going to have to pay, right? Let's see what else is that. Okay, let's look at part B. It says, consider the population of a city and the number of letters in the name of the city. Would you expect a positive correlation, a negative correlation, or no correlation between the two sets of data? Explain your reasoning. So the population of a city and the number of letters in the city, I'm going to have to say there's no correlation. And explain my reasoning. I see San Francisco, for example, that has a large population and has a lot of letters. Atlanta, it has not as many as San Francisco, but it also has a large population. New York doesn't have as many as San Francisco, many letters, but it still has a very large population. So as you can see, it doesn't matter the number of letters to the amount of people in the city, that doesn't have anything to do. So those things are not correlated. I hope that this helps.